In the cold vacuum of space, 1.8 billion light-years from Earth, there lies a galaxy that shouldn't exist. It spins the wrong way, radiates impossible energy, and houses stars older than the universe itself, if that's even possible. Astronomers first dismissed it as a data error. But when the James Webb Space Telescope locked onto its haunting light signature, the truth began to unfold. This wasn't just strange, it was impossible. In a cosmos bound by predictable physics, this galaxy is a ghost, mocking everything. We thought we understood about time, gravity, and the very birth of existence. What if we've been looking at the universe backward? Subscribe if you believe the universe still hides secrets no one is ready for. Join us as we travel to the edge of knowledge where physics breaks down and reality itself is up for debate. It started with a whisper, not a sound, of course, but a sliver of light. A whisper written in photons, stretched thin by the expansion of time itself. The Atacama Desert, high in the Chilean mountains, is one of the driest places on Earth. But it is also one of the most silent. Here, surrounded by salt flats and lunar terrain, sits the Atacama Large Millimeter Array, ALMA, a forest of radio telescopes constantly listening to the cold murmur of the cosmos. On a freezing morning in June, Dr. Elena Moretti stared at a strange signal blinking across her monitor. It looked like noise, a misfire, the kind of spectral irregularity you'd get when a satellite passes overhead or a distant pulsar, hiccups. But there was something off. Its redshift placed it nearly 2 billion light-years away, older than our Sun, older than Earth's continents, and yet the pattern shimmered, repeating every 19 hours and 46 minutes. Exactly. Dot signals don't repeat like that. Not without intention, she flagged it for the team. A junior astrophysicist ran it through the database, expecting to trace it to a known quasar or dying star. Nothing matched, so they checked again and again. The same anomaly, the same heartbeat. Every time, at first, no one cared. Space is full of oddities: gravitational lensing, cosmic microwave echoes, data artifacts. But then Hubble picked it up. A deep field image from 6 years earlier showed a faint, spiraled glow in the same position. Faint, almost translucent, like a ghost peeking through the veil. It was designated XGZ-91b, just another alphanumeric stamp among billions. But the deeper they looked, the more the galaxy began to unravel the rules of reality. The light it emitted was bent in impossible ways. It had a mass signature far too small for its radiance, and its spectral lines were inverted, as if you took a typical galaxy and flipped its DNA. Dr. Moretti described it as a scream muffled by time. That's when the whispers turned into alarm bells. When James Webb came online, the team lobbied to prioritize a high-resolution image of the region. Time on Webb is precious. Nations and institutions fight for seconds of observation. But when Webb's instruments finally locked onto XGZ-91b, it confirmed everything they feared. And more, the galaxy wasn't just spinning strangely. It was spinning the wrong way. Its arms wound clockwise against the flow of nearly every other spiral galaxy in the observable universe. And not only that, the spin didn't match its structure, the dust lanes, star distribution, gravitational curve. None of it made sense. One researcher simply whispered, "It's mocking us." Back in the ALMA control room, scientists began asking darker questions. Was this some strange effect of lensing? Could a black hole be distorting our perception? Or was XGZ-91b operating under a different set of physical laws. And here's where things got truly unsettling. The galaxy appeared to be stable, not falling apart, not in collapse, not anomalous for a moment, but for eons, like a watch that ticks backward but never loses time. Astronomers try to replicate the readings, simulate its structure, predict its evolution. Every model failed. The gravitational field surrounding it didn't behave. The expected stellar drift wasn't there. It was as if the galaxy was locked in defiance, immune to entropy. But how? Theories began to form, some grounded, others speculative. Maybe it was a gravitational mirror, a dimensional scar, a collapsed filament from another universe. Maybe it was a primordial remnant, a leftover from the Big Bang that never played by the rules. Dr. Moretti, normally the picture of scientific rigor, confessed during an interview it feels deliberate, like it's trying to be seen. The statement sparked debate across astrophysics forums. Conspiracy blogs latched on. SETI even reopened archived data to cross-check for intelligence signals in the region. Nothing obvious. But that didn't stop the theories from spreading. Still, the team pushed forward, driven not by fear or fantasy, but by the unmistakable pull of discovery. They needed to know, what is XGZ91b? A quirk, a threat, a message, or something worse, because if this galaxy could exist against all logic, against all physical law, what else could be out there? And perhaps more hauntingly, what if it's not alone? We thought we understood the script of the universe, but now a new character had entered the stage, and it wasn't playing by our rules. Archived data is the astronomer's time machine. Every snapshot taken by Hubble, Keck, Spitzer, they all live in massive digital vaults, waiting to be re-examined under new light. And that's exactly what Dr. Rajan Patel from Caltech decided to do, while Moretti's team at ALMA confirmed the recurring signal. Patel dug into the past, sifting through deep field images from over a decade ago. They're buried in pixels. XGZ91b stared back like a ghost caught in the corner of an old photograph, dim, misaligned, but undeniably present. But then came something even more curious. Its spiral arms, galaxies typically wind in the direction of their angular momentum, a memory of the primordial forces that spun them into being. Most follow this cosmic choreography. XGZ91b does not. Its arms curved clockwise, directly opposing the flow dictated by surrounding galactic structures. This isn't just weird, it's astrophysical heresy. Dr. Patel ran simulation after simulation. Could this be the result of a major collision, a galactic merger? Maybe. But the symmetry was too perfect. There were no tidal tails, no signs of disruptive gravitational trauma. If anything, the galaxy looked pristine, untouched by the chaos usually required to produce such a reversal. More unsettling still was its redshift profile. According to our models, this galaxy should have existed during a cosmic era still, dominated by turbulent gas and violent collisions. Yet XGZ91b appeared calm, mature. Its stars were unusually stable, their spectra indicating chemical compositions too enriched for their supposed age. This implied generations of star death, rebirth, and metallic fusion, all taking place when the universe itself was still in its infancy. It was as if this galaxy had skipped cosmic adolescence and gone straight to middle age. What we're seeing, Patel explained in a press conference, is a fully evolved spiral galaxy appearing billions of years before it has any right to exist. It's like finding a 50-year-old human in the maternity ward. The media dubbed it the ghost galaxy. A relic, a rogue, a temporal outcast drifting in defiance. At the far edge of what we thought was possible. But anomalies alone aren't enough to rewrite cosmology. What caught the attention of the global scientific community was how precisely wrong this galaxy was. Every measurement violated the expected trajectory, but in a way that was consistent, systematic. Imagine throwing a ball into the air and, instead of falling, it hovers every time at the same altitude, defying gravity with clockwork predictability. At some point, it's no longer an anomaly. It's evidence of another rulebook. By the time the James Webb Space Telescope gathered its first data, XGZ-91b had become a full-scale obsession. Its infrared scan revealed even more mysteries. Dust lanes that absorbed too much light. Regions of active star formation where temperatures were inexplicably cool. But the real shock came from the galaxy's core. In typical spirals, a supermassive black hole anchors the center, feeding, spinning, distorting space around it. But in XGZ-91b, the core appeared. Hollow, not empty, but transparent. No gravitational. Well, no X-ray emissions. Just a glowing, diffuse region shaped like an iris, like an eye, watching, of course. That's metaphor. Science doesn't indulge in. But even seasoned researchers admitted to an emotional response, an intuitive discomfort, a feeling that this galaxy knows we're watching it. One technician described looking at the data as like staring into something that stares back. Re-entered the conversation. Spectral lines were analyzed for artificial modulation. No patterns were confirmed, but the lack of randomness in the energy emissions raised eyebrows. Randomness is nature's fingerprint. XGZ-91b looked suspiciously intentional. Across labs, theories began to fracture. Some speculated it was an alternate universe bleeding into ours, a region where time and matter evolved faster. Others revived the idea of cosmological inflation pockets, suggesting XGZ-91b existed in a bubble where different physical constants applied. A few ventured further, invoking simulation theory. What if this galaxy isn't broken? What if it's inserted? Test. A probe. A feature in the code. Suddenly, cosmology didn't feel so objective. It felt personal. But here's the twist. This isn't just about one galaxy. Because if a single galaxy can defy the rules, if one rogue spiral can age too fast, spin backward and emit light from nowhere, then the entire framework of our universe comes into question. How many other galaxies have we misread? How many strange lights were discarded as bad data? Maybe we haven't discovered XGZ-91b. Maybe we've finally noticed it. And what if it noticed us first? When the James Webb Space Telescope shifted to deeper infrared scans, it wasn't just looking at structure. It was peering into the history of light itself. And what it revealed about XGZ-91b made even seasoned cosmologists question reality. Its star-forming regions behaved in reverse. Typically, clouds of hydrogen and helium collapse under gravity, ignite under pressure, and give birth to new stars. Over millions of years, these stars burn, swell, and die in spectacular supernova, dispersing heavy elements into space. But in XGZ-91b, the light told a different story, a story where that sequence unraveled in reverse. Vast stellar nurseries, once thought to be birthing stars, were actually contracting from luminous configurations into compact gas clusters. Spectral analysis suggested these weren't early formations. they were unforming, like watching ashes become fire, and then collapse back into logs. And it wasn't an illusion, not lensing, not interference. Every reading confirmed the same bizarre trend: energy bleeding inward, entropy reversing, stars becoming denser and younger with time. In Earth-based labs, entropy is law, the arrow of time. It governs everything from melting ice to decaying galaxies. But what if that arrow could bend? Dr. Anaya Korn, a theoretical physicist from Seoul University, was among the first to publicly propose a radical framework. This galaxy, she said in a now viral symposium, might be inside an entropic bubble, a local reversal of thermodynamic flow. It's like a knot in the tapestry of space-time, one formed not by chance, but perhaps by trauma. A trauma. What kind of cosmic wound could cause time itself to run backward? The leading hypothesis was this: sometime after the Big Bang, fluctuations in quantum fields could have produced localized entropic inversions, regions where the usual progression of time broke down. In simulations, such regions would quickly collapse, swallowed by entropy's overwhelming momentum. But if one survived, shielded, isolated, it might appear exactly like XGZ91b, a galaxy where time runs against the current. Webb's gravitational lensing data added another layer. Light from the galaxy bent in bizarre asymmetric patterns, as if the fabric of space around it wasn't just warped, it was folded. The distortions weren't random, they were rhythmic, like ripples from a dropped stone, but pulsing outward. From the core in regular, time-defying intervals, the term time lens was coined. A region where time itself might be looped, knotted, or fragmented. Not a black hole, not a wormhole, something else, something subtler. Like watching a movie in reverse and realizing it still makes sense, just in a language you don't yet understand. But here's where things grew even stranger. High-resolution, spectral imaging revealed traces of elements that should no longer exist, short-lived isotopes with half-lives far too short to survive billions of years. Yet there they were, in abundance. Not decaying, but reconstituting. It was as if the galaxy was remembering its past in real time. This prompted a new wave of questions. Is XGZ91b an echo of a previous universe? A leftover region of reversed entropy from a pre-Big Bang event? Or are we witnessing something far more complex? A new class of cosmic object entirely, one that obeys unfamiliar rules. Kwon and her team proposed a metaphor. Think of the universe as a river. Most galaxies drift downstream, their matter and energy carried forward by time. But every so often, in the turbulence of quantum chaos, a whirlpool forms, spinning matter, not forward, but backward. XGZ91b may be such a whirlpool, not an error, but a feature. And if that's true, then our assumptions about time, its direction, its uniformity, its inviolability may be wrong. This raises profound implications. Could other such time knots exist? What happens at the boundary where forward time meets reverse time? Would that interaction generate energy? Could it destroy information? Could it erase causality? One proposed experiment suggested tracking gravitational waves emitted from the galaxy's core. If XGZ91b is reversing entropy, then its gravitational signature should show time-compressed frequencies, essentially echoes arriving before their cause. So far, the data is inconclusive, but disturbing. A few bursts do appear to arrive, slightly out of sync with expected wavefronts. Not enough for confirmation. but enough to keep the question alive. And if time can run backward there, could consciousness exist within it? Could observers, however alien, evolve in reverse? Would they experience memory as prophecy, death as birth, cause as effect? Would they perceive our universe as the one running wrong? Pause for a moment and think. If you were born into a galaxy where time flows backward, and you suddenly glimpsed our world, would we seem like ghosts trapped in a future you've already forgotten? What would that mean for everything? Spinning is second nature to the cosmos, from planets to stars to entire clusters of galaxies. Everything moves, carried by the residual momentum of the Big Bang. Galaxies, in particular, are rotational giants. Their arms stretch out like the spiraling currents of a cosmic hurricane, each twist and turn a direct consequence of gravity, angular momentum, and mass distribution. But when scientists at MIT began analyzing the rotation of XGZ 91b, what they discovered defied every one of these principles. The galaxy wasn't just spinning in the wrong direction, it was spinning without reason. In a universe governed by cause and effect, that's not supposed to happen. Dr. Maya Hansen, a computational astrophysicist leading the MIT team, stared at her simulation models for days. The numbers were clean, she recalled, but the results were dirty, offensive, even it's like watching a wheel spin without anything pushing it. Normally, a galaxy's spin can be traced to its formation history, gravitational collapse, early asymmetries, interactions with nearby matter. The spin direction, velocity, and stability are all derived from physical inputs. But with XGZ 91b, these factors didn't add up. Its mass was too low to sustain its rotation. Its surrounding space lacked nearby galaxies that could have slingshot it through gravitational influence, and there was no evidence of a central black hole exerting the dominant forces usually required to organize such a large structure. In short, it was spinning in spite of everything. Worse still, its rotational speed wasn't decaying. In most galaxies, frictional forces from dark matter halos, interstellar gas, and radiation gradually slow their spin over billions of years. But in XGZ 91b, that spin was accelerating ever so slightly, like a ballerina pulling in her arms except with no arms to pull in and no dancer behind the motion. One proposed idea was that the galaxy harbored an exotic form of matter, something denser, colder, or stranger than dark matter. Perhaps a kind of mirror mass, invisible but present, providing the angular torque. But if such material existed, it would change everything we know about cosmological mass energy distribution, and it would have been detected elsewhere. So far, no sign. Others suggested a kind of magnetic torsion, a massive galactic-scale magnetic field, creating internal pressure. But this too fell apart under scrutiny. The field lines were chaotic, fragmented, nothing consistent enough to explain the rotation. If anything, the magnetic data made the mystery worse. Field vectors curved in impossible ways, as if responding to forces that don't exist in our known dimensions. One young postdoc during a closed-door conference at CERN offered a wild idea. What if XGZ 91b is spinning because of something outside our universe? Not within space, but acting upon it. His voice was met with silence, not out of ridicule, but caution. Because if such a thing were true, it would hint at extra-dimensional interference. Imagine if someone outside a snow globe reached in and stirred the particles with a finger. That's the analogy being whispered in the darker corners of theoretical physics. There's another, more unsettling interpretation. If XGZ91b isn't obeying any known force, maybe it's being sustained, maintained, kept in motion not by physics, but by function, as if it was designed to do this. Spin endlessly, predictably, in open defiance of natural decay. But what purpose would such a system serve? A beacon, a battery, a lock? This idea, the notion that the galaxy may be artificially sustained, sent ripples through the scientific community, not because it implies intelligent design necessarily, but because it implies non-natural persistence. In nature, everything degrades, everything ages, but not XGZ-91b, no supernova remnants, no starbursts, no gravitational scattering, just motion, endless, deliberate motion. As news of these anomalies spread, a pattern emerged among scientists. Across continents, a sense of quiet unease, not fear, not excitement, but a deep, gnawing discomfort, as though the universe had always whispered a reassuring lie that it obeys rules, and that those rules are eternal. And now, one galaxy had pulled back the curtain. MIT's final report didn't offer a conclusion. Instead, it ended with a question. What is the source of this galaxy's spin, and what does it mean for our cosmological framework? But maybe that's the wrong question. Maybe we should ask, what if our laws of physics are the anomaly, and XGZ91b is the rule? And if that's the case, how many more rules are we about to break? Starlight is memory. Every beam that touches our telescopes carries the story of its origin, its age, composition, even the environment it was born into. By decoding that light, we time travel. We reconstruct moments long dead and buried beneath the ever-expanding skin of the cosmos. But what happens when that memory is wrong? Inside the strange spiral of XGZ91b, scientists began analyzing its stars, not just their brightness or distance, but their elemental makeup, the fingerprints of nuclear fusion. And that's when the narrative began to fracture. Dr. Lena Granger, a stellar evolution specialist at the Max Planck Institute, was one of the first to sound the alarm. These stars, she said, holding a printout of spectral signatures, shouldn't exist, not at this time, not in this place, not like this. The problem wasn't just their age, it was their chemistry. Stars are made mostly of hydrogen and helium, but as generations of stars live and die, they scatter heavier elements, carbon, oxygen, iron, into the interstellar medium. Young stars have fewer of these metals. Older stars, born later in a more enriched universe, have more. But the stars in XGZ91b were backwards. Many showed metallicity levels consistent with population 2 stars, ancient stellar bodies, thought to form just after the first, most primitive generation. Some even hinted at characteristics closer to hypothetical population 3 stars, which, until now, had never been directly observed. If confirmed, that would place their birth within a few 100 million years of the Big Bang. That's already shocking, but the real terror came when one group of stars, deep within the galaxy's core, was dated through multiple independent methods to be over 14 billion years old. The universe itself is only 13.8 billion years old. Let that sink in. A star cannot be older than the fabric it was born into, unless something is very, very wrong with our understanding. Was it a miscalculation, a fluke? Radiation contamination? Granger's team triple-checked. Then a second lab in Australia replicated the results using entirely different data. They got the same answer. Suddenly, the idea of impossible stars became more than poetic. It became real and dangerous, because if stars older than the universe exist, then our model of the cosmos, with its singular beginning and smooth unfolding, may be broken. Some speculated the stars could be survivors, ancient objects formed in a prior cosmological cycle, remnants of a pre-Big Bang era, preserved and carried over by unknown mechanisms, like fossils embedded in space itself. This called to mind the controversial work of Sir Roger Penrose, who proposed conformal cyclic cosmology, a theory suggesting that the universe undergoes infinite cycles, each ending in a kind of quiet fade before rebooting into a new expansion. Under this model, some information or even matter might survive from one eon to the next. Penrose had long been dismissed by many in the mainstream, but now whispers of his theory began circulating in serious journals. What if XGZ91b is not a product of this universe, but a memory of the one before? Such a relic would not only be rare, it would be sacred, a message from a previous reality. And yet, there it was, orbiting calmly, as if daring us to understand. Even more unsettling were the physical states of these ancient stars. They weren't dimming. They weren't collapsing into white dwarfs or neutron cores. They were stable. Too stable. Their fusion rates, magnetic behavior, even surface temperatures were oddly uniform, like time itself had no grip on them. One possibility was that these stars weren't made of ordinary matter at all, but something exotic. Some even theorized they were composed of pre-quantum matter, predating the known for fundamental forces that would explain their longevity. But it wouldn't explain how they got here, because to survive from a previous universe, they would have to cross the singularity, the moment when all of space, time, energy, and logic condensed to an infinitesimal point, a point where no information should survive, a point where even the concept of before becomes meaningless, unless the singularity isn't what we think it is. What if it's not a wall, but a bridge? And what if XGZ91b is the traveler that walked across? Scientists around the world now debate not whether the stars are older than time, but what kind of time they come from. Is it a looped time, a mirrored time, a time outside of entropy altogether? And if so, what else might have crossed with them? Because where there are stars, there may once have been civilizations, and if those two survived, who or what might they have become? There's a theory whispered first among outliers, then cautiously adopted by mainstream thinkers, that the universe is not a one-time event, but part of a cycle, not a line, but a loop. What dies returns, what ends begins again. And somewhere, in that endless rotation, a signal might survive. The idea is called conformal cyclic cosmology, first proposed by Sir Roger Penrose. It suggests that when a universe reaches maximum entropy, when all black holes evaporate, all stars go dark, and space itself becomes quiet, the distinctions between big and small vanish. Time stretches to infinity, and then resets. A new Big Bang, a new AEON. Most treated it as elegant speculation, until XGZ91b, the stars within it, already suggested something ancient, impossibly so. But it was what came next that shifted the conversation from theoretical to urgent. In a joint study between the European Space Agency and Tokyo University, gravitational wave detectors picked up a strange echo, not from a neutron-star merger, not from a black hole collision, but a rhythmic pulse, quiet, uniform, persistent, and it came from the direction of XGZ91b. What made it extraordinary wasn't just its regularity. It was the signature. It matched faintly, but measurably, a pattern discovered years earlier in the cosmic microwave background, the leftover radiation from the Big Bang. Some cosmologists believe these patterns are the fingerprints of massive black hole collisions from a previous universe, disturbances imprinted into the fabric of this one. Penrose called them Hawking points. But until now, no known object had ever echoed them. XGZ91b did. Its gravitational pulses followed the same intervals, the same harmonic ratios, like hearing a forgotten melody replayed on a different instrument across time. And that's when people started using a new word to describe this galaxy: relic. Not just an ancient galaxy, but a surviving artifact, a cosmic fossil, or worse, a seed. What if XGZ91b didn't just survive the transition between universes? What if it was meant to? Imagine this: as the last universe faded, some intelligence, or process, or unknown mechanism prepared a payload, a capsule of matter and memory, wrapped in quantum insulation, designed to pierce through the singularity and emerge intact on the other side. It wouldn't look like a spacecraft. It wouldn't need engines or shielding. It would look exactly like XGZ91b, an unassuming spiral, rotating quietly in defiance of all natural law. And if that's true, what else could have made the crossing? Because no seed is planted without intention. Dr. Malachi Rhodes, a cosmologist at Oxford, gave voice to the question many had started to fear: if this galaxy is from a previous eon, and if it was designed to survive, was it merely a relic, or a message, or worse, a mechanism? Could XGZ91b be doing something? A function, a purpose, encoded not in language but in spin, light, and gravity. Researchers are now hunting for patterns, prime number sequences in its pulse rates, geometric harmonics in its star arrangements, possible signal modulations in its energy emissions. Nothing definitive, but then again, maybe we're looking the wrong way. Maybe the message isn't meant for us, or maybe we're not yet capable of reading it. The possibility that we are living in a recycled universe is unsettling. It means that everything we think of as permanent atoms, laws, space, time, are just configurations in a repeating cycle, that even death itself is just an intermission. But it also opens a darker door, because if something survived, it might remember, and if it remembers, it might be waiting for the right moment, the right conditions to awaken, or replicate, or unfold into whatever it was always meant to become. Not all seeds bloom immediately. The last paragraph in Dr. Rhodes's paper is chillingly poetic. In the ruins of the before time, the universe may have planted a question. It took 14 billion years to reach us. Now we must decide whether to answer. And so we stare back at XGZ91b. This quiet, spinning enigma and wonder. Is this the first whisper from the universe before ours, or the last breath before it begins again? Light is the language of the universe. From radio waves to gamma rays, every photon carries a fragment of its origin, a whisper of its past, a trace of its path. And for decades, we've used this language to map galaxies, measure stars, and decode the very birth of time. But then came a signal from XGZ91b that didn't fit any known dialect. It began with a low hum, not audible, but visible. a background frequency that shimmered just beneath the standard electromagnetic spectrum, detected by the ultra-sensitive dishes of the Square Kilometre Array in South Africa. This hum wasn't static. It pulsed faintly, like the throb of a distant engine or a heartbeat. But what truly shook researchers was that the hum wasn't limited to radio. It spanned the entire spectrum, rising into the microwave band, dipping into X-rays, even brushing the elusive territory of gamma. And stranger still, the frequencies weren't continuous. They skipped, like stones across the surface of a lake, jumping from one range to another with precise, impossible rhythm. This wasn't natural in astrophysics. Most energy emissions follow patterns governed by thermodynamics, motion, or atomic transitions. But this, it resembled structured modulation, a kind of pulse code, and when plotted visually, the intervals formed a repeating pattern, one that didn't align with any known astronomical process. Some tried to dismiss it as interference, reflections from Earth-based signals. But the readings came from multiple observatories, isolated continents apart, and confirmed by space-based instruments. This signal wasn't Earthborn. It was ancient, and it was real. Dr. Omar Salim, a quantum physicist at CERN, was called in to consult. His first reaction: this isn't light anymore. This is instruction. He hypothesized that what we were seeing might be a side effect of time refraction, a theoretical phenomenon in which time itself, like light through a prism, bends differently across regions of space with exotic physical properties. In this model, if XGZ91b were embedded within such a region, then the light it emits would carry time-distorted information. Frequencies would behave abnormally, arriving out of order, skipping harmonics, reversing phase. It would look, in other words, exactly like what we were seeing. But Salim took the theory further. He proposed that we weren't just detecting warped frequencies, we were witnessing interdimensional interference. That is, interactions between our universe and a neighboring dimension with different temporal or energetic constants. Think of our universe as a thin sheet vibrating in a higher dimensional space. Occasionally, that sheet touches another, and when it does, energy crosses over, not explosively, but subtly, quietly, through hums, through skipped frequencies, through forbidden light. To test this, researchers ran a spectral decomposition, using a Fourier transform, essentially breaking the signals down into their fundamental mathematical components. What they found stopped them cold. The patterns included prime sequences, repetitive cycles nested within larger cycles, ratios reminiscent of the golden mean and Fibonacci spirals. These are not random. These are mathematical fingerprints, not of a civilization, necessarily, but of design. This discovery reopened an old question in science. Where do the laws of physics come from? Are they emergent properties of our universe's birth? Or are they imposed, coded from somewhere beyond? Because if XGZ91b is producing mathematically perfect frequency structures across impossible wavelengths, then it's not just violating our laws. It might be writing its own. Some scientists, carefully, have begun referring to these emissions as protocols, not signals, not radiation, but active processes, operations, instructions, possibly governing matter or entropy within the galaxies. Domain. But if these are protocols, who or what initiated them? That's when things took a more chilling turn. One portion of the frequency range, a high-energy burst in the terahertz spectrum, repeated every 243 hours. On a hunch, A group of analysts from JPL ran it through a time compression algorithm, adjusting for relativistic distance and suspected time distortion. The compressed signal resembled a sequence of pulses that repeated exactly 91 times, 90-1. The same number embedded in the galaxy's designation, XGZ91b. Coincidence? Or message? Some now believe the naming wasn't random, that the galaxy somehow imprinted its numerical identity through the signals we would later receive, that it was, in some strange way, anticipating our discovery. And if that's true, who is it speaking to, us or something else? Because if these frequencies are crossing dimensions, then they're not just echoing into our universe, they might be reaching out to others. And if that's the case, we have to ask, are we eavesdropping on a conversation that was never meant for us? Back on Earth, behind radiation-shielded walls and surrounded by arrays of supercooled processors, scientists attempted the unthinkable to simulate XGZ91b, not just its light or its structure, but its physics. What laws governed this rogue spiral that spins without cause, emits forbidden frequencies, and houses stars older than time? If we couldn't explain it observationally, perhaps we could rebuild it virtually. So began the Paradox Engine project, a collaboration between NASA, CERN, and Japan's Riken Computational Lab. For the first time, their combined super resources were dedicated to modeling a single galaxy. The goal: create a digital twin of XGZ91b, using every known physical constant. The result? Failure, not the kind that comes from bugs or memory limits, but a fundamental kind where the code runs, but the outputs defy logic. Galaxies collapsed instantly, spun into ribbons of chaos, or vanished into numerical infinity. So the team adjusted. They tweaked parameters, loosened constraints, added variables from theoretical physics, exotic matter, negative energy density, non-Euclidean curvature. But every simulation, without exception, self-domained, not because of overload, but because it couldn't exist. It was as if the laws of our universe were incompatible with whatever this galaxy is. Then came a breakthrough. Dr. Hanoko Watanabe, a young postdoctoral theorist, introduced a variable she called temporal asymmetry bias. In simple terms, she allowed the arrow of time in the simulation to bend, to reverse locally, or loop. It wasn't traditional physics. It was borderline science fiction, and yet, for the first time, the model stabilized. Not perfectly, but enough to hold for 13 simulated seconds. During that time, the galaxy spun, stars ignited, and matter flowed backwards through filaments of space. But the strangest part wasn't the motion, it was the output. The galaxy began to generate data, equations, pulses, self-organizing patterns emerging from entropy. The simulation wasn't just behaving, it was calculating, like a machine, like an engine. Scientists stared in stunned silence as their screens flooded with recursive fractal expressions, Mandelbrot-like spirals nested inside gravitational maps. One researcher, voice trembling, asked aloud, "Is it solving something?" No one could answer, but the implication was inescapable. XGZ91b, under simulated conditions, functioned like a computational system using gravity, light, and time itself as input variables. And if it was calculating, then what problem was it trying to solve? One idea took root. Maybe this galaxy is a processor, a cosmic-scale computer running a single massive equation, one we were never meant to see. The term Paradox Engine became more than a project. Title: it became a name. Physicist Dr. Jules Ferreira likened it to a cosmic Turing machine, one that doesn't operate through wires or logic gates, but through the very structure of space-time. The fabric of this galaxy, he wrote, may not be natural, it may be code. Executing this concept isn't new. Theoretical frameworks like digital physics and pancomputationalism suggest that the universe itself might be a simulation, or at least computational in nature. But never before had a physical object behaved so deliberately as a processor. Even the galaxy's strange spin could be explained, not as motion, but as a loop function, a cyclical input, a cosmic clock cycle. But cycles require purpose, function, direction, so again, the question emerged, what is it computing? And here, the theories diverged. Some believed it was trying to reverse entropy, a self-contained attempt to escape thermodynamic death. Others proposed it was simulating universes, testing variations of constants in search of survivable outcomes. One paper, quickly retracted but widely discussed, proposed that the galaxy was predicting us, that its calculations aligned with Earth's own developmental curve, as if it were anticipating intelligence in the cosmos. But perhaps the darkest theory came from a team at the Max Planck Institute. They suggested that XGZ-91b was not an engine at all, but a lock holding back something else. And now that we're watching it, simulating it, decoding its pulses, and mimicking its motion, maybe we're turning the key, because in every simulation run past the 13-second mark, the system destabilized violently. Singularities appeared, laws collapsed, the simulation tore itself apart from within. Each time, the final output was the same, the null set, emptiness, as if, beyond a certain threshold of understanding, the galaxy erases the question itself. So, now we sit with our screens and our equations, watching the impossible spin quietly from across the void. An object that defies entropy, emits instructions, computes in silence, a paradox wrapped in gravity, and we're left with a choice. Do we keep simulating, or do we stop, before the lock fully opens? The farther we look into the cosmos, the more we expect to find silence, not because space is empty, but because it is vast. Galaxies are flung across the universe like scattered embers, grouped into filaments and superclusters, separated by unimaginable stretches of nothingness. These voids, cosmic gulfs, billions of light years wide, are thought to be cold, quiet, and still. But what if they aren't? Weeks after the paradox engine simulation imploded for the 5th time, something changed. A team at the Vera C. Rubin Observatory, scanning a dark patch of sky for signs of deep transients, noticed a flicker. Not a light, not a signal, but a gravitational ripple, faint, like the tremble of a leaf in the breeze. Initially dismissed as background noise, it was only after comparing multiple passes that they realized the ripple was moving, slowly, purposefully, like something drifting in the void. They turned their instruments toward the anomaly and intensified the resolution. That's when they found it, another spiral galaxy, smaller, fainter, but undeniably strange. Its structure was distorted, like a spiral seen through warped glass. Its core wasn't bright, but dark, not because of black hole activity, but due to an eerie absence of electromagnetic emission. The entire galaxy seemed hollowed like a seashell, still spinning, still intact. It bore an uncanny resemblance to XGZ-91b, designated XGZ-91c. This second galaxy shared not only a similar spectral profile, but the same impossible spin, clockwise, reverse-handed dot, and once again, its light signature pulsed in skipped frequencies, a sibling, a twin, a second impossible thing. But here's what truly broke the silence. When the signals from XGZ91b and XGZ91c were overlaid, something emerged, a pattern. The two galaxies were in harmonic resonance, like twin tuning forks vibrating in sympathy. Across cosmic distance, the frequencies, when combined, formed a beat, an interference pattern of perfect mathematical symmetry. It was as if they were speaking to each other. Now, the silence between galaxies seemed far less empty, more like a void with echoes. Physicist Dr. Raina Voss led the team decoding the resonance. She described it like hearing the harmonies of two singers performing a duet in different rooms. There's call and response, she said. You can hear one leading, the other following. What does that mean? It could be coincidence, a natural resonance caused by gravitational wave interaction, or it could be communication, because the beat frequency, the pattern created by the interference, wasn't random. It repeated every 327 hours, precisely. A prime number and primes, throughout human history, have been the foundation of all artificial signal detection efforts, because they rarely appear in nature. They are pure, intentional. So now, scientists ask, if there are two, are there more? Dozens of observatories began combing the void between galaxies. Most looked in vain. But in one case, a candidate emerged, a faint infrared source, even more distant, bearing the same warped geometry and odd spin. If confirmed, this would make three, a triangle, a network. Suddenly, a terrifying possibility takes shape. What if these galaxies aren't accidents? What if they're placed, deliberately distributed throughout the cosmic web, distant enough to avoid detection, but close enough to remain connected through gravity or quantum entanglement? What would such a network be for? Data storage, cosmic processing, or surveillance? It might sound like science fiction, but if XGZ91b and its siblings are computational engines, paradox machines, then placing them across strategic locations in the fabric of space-time could serve a purpose beyond our understanding. Imagine a distributed intelligence, galaxy scale, embedded across the universe like neurons in a vast brain. Are we living inside a mind? And if we are, is it awake? The implications shatter every assumption. The cosmic void, once considered a meaningless emptiness, now pulses with potential intent. We've always assumed the silence between galaxies meant there was nothing there, but maybe we weren't listening the right way. Maybe the void isn't silent at all. Maybe it's waiting. And now that we've found the first chords in this strange cosmic symphony, we must ask ourselves, have we stumbled upon the opening bars of something far more complex? Or are we already in the middle of the song, and only just beginning to hear the melody? There comes a moment when coincidence becomes design, when the puzzle pieces no longer scatter at random, but begin to form the faint silhouette of something intentional. That moment arrived when the third galaxy, XGZ91d, was confirmed nearly 3.4 billion light-years beyond its siblings, but exhibiting the same impossible traits: reverse spin, time-bending signatures, and gravity-borne pulses that fit perfectly into the growing resonance pattern. 3 galaxies, 3 locations, 1 rhythm. They weren't random anymore. They were placed. That's when scientists began using a new term, quietly, cautiously, and only in private circles. At first, the architect hypothesis, The idea that the galaxies were constructed, engineered, not by stars and gravity and cosmic coincidence, but by something or someone, a presence so far beyond our understanding, it might as well be divine. It sounds outrageous sacrilege to centuries of naturalistic science. But the evidence grew harder to ignore. The resonance between the galaxies didn't just harmonize, it scaled. XGZ91D's signal didn't disrupt the duet between 91B and 91C. It completed it. 3 points forming a spatial triangulation. And when mapped in four-dimensional space-time, that triangle extended, forming a tetrahedral grid, a geometric lattice, intentional geometry in a universe ruled by chaos. And yet, there it was. Dr. Kavita Rao, a SETI veteran and lifelong skeptic of cosmic engineering theories, reviewed the data herself. She found no flaws in the measurements. Either the laws of physics are conspiring to prank us, she wrote, or we are standing in the shadow of something vast, something that thinks in galaxies. That sentence spread like wildfire, because it implied motive, and motive implies mind. What kind of intelligence could build or seed galaxies as instruments of computation, resonance, or containment? The answer brings us face to face with the Kardashev scale, a theoretical framework, measuring civilizations by their energy use. Type I harnesses the power of a planet, Type 2, a star, Type 3, an entire galaxy. But what we were seeing now pointed to something beyond, something that doesn't just harness galaxies, but constructs them, uses them, organizes them. Like components in a machine. We call it Type 4, a civilization that has mastered the fabric of space-time, itself bending entropy, manipulating gravity, rewriting the constants we thought were sacred. Perhaps that's why XGZ91B behaves the way it does. It's not defying physics. It's operating on a version of physics authored by its creator. If this is true, the implications are staggering. The universe we see, with its chaotic scatter of stars, its lonely planets, its dark voids, may not be natural at all. It may be a design, a system, a mechanism with rules, constraints, and intentional anomalies. The paradox galaxies could be control nodes, beacons, or locks. Because there's one theory, rarely published, but whispered in late-night research calls, that chills even the most seasoned physicists. The galaxies aren't messages, they're barriers, constructs placed like runes along the edges of space-time to contain something, or someone, a presence from the before-time, a leftover intelligence, or a force that cannot be allowed to awaken. And now we, in our curiosity, our ambition, our desperate need to know, may be tampering with that lock, but not all interpretations are dark. There are those who believe. The architect, if it exists, may have placed these galaxies not as warnings, but as breadcrumbs, an invitation, a challenge, the ultimate signal to intelligent life that the universe is not only alive, but aware. One final detail lends credence to this hope: the gravitational rhythm of the three galaxies, when sonified and accelerated too. Human hearing range produces a tone haunting, harmonic, and eerily familiar. It resembles a musical chord found in ancient Earth cultures, a minor triad, a melody humans have used for mourning and awakening, coincidence, or recognition. So, now the question stands: are we decoding the echoes of a grand design, or are we standing at the threshold of a door never meant to be opened? And if there is an architect, what does it want us to see? In quantum mechanics, There's a rule that haunts physicists like a ghost behind the curtain of reality. The act of observation changes the observed. Particles behave like waves until you look. Then they collapse, choosing a state, as if reality waits to make a decision until it knows someone's watching. Now imagine that principle scaled up, not to atoms, but galaxies, because ever since humanity focused its most powerful eyes on XGZ 91b and its siblings, something strange has been happening. The signals are shifting. Slightly, subtly, the pulse intervals, once clockwork precise, have begun to drift by fractions of microseconds. The spin rate of XGZ 91c appears to have increased by an immeasurable but mathematically significant amount. Tiny variations, easy to dismiss unless you know what you're looking for. A team at the University of Toronto, led by quantum information theorist Dr. Leila Moreno, compiled these anomalies. Her conclusion was unsettling. The act of observation is feeding back into the system. The galaxies are responding. Responding how and to what exactly? To our instruments, our thoughts, our presence in the data stream. Moreno proposed a terrifying possibility that by studying these galaxies, measuring them, simulating them, sonifying them, we are not just observers, we are participants. Interlocutors in a conversation we didn't know we had started. The concept quickly became known as the observer's dilemma, a philosophical and scientific paradox suggesting that consciousness, or at the very least intelligent awareness, plays an active role in shaping the behavior of XGZ 91b and its siblings. Think of it like Schrodinger's cat, but scaled to cosmic proportions. If no one looks, perhaps the galaxies remain stable, predictable, inert. But once we observe, once we ask questions, the system responds. Not necessarily out of intent. Maybe it's just how it works. But what if it's more? Consider the concept of a feedback loop. We observe, the signal changes. We observe again. The change accelerates. A recursive interaction unfolds, not unlike a hall of mirrors or a microphone left too close to a speaker. Could this be happening now, across billions of light years? A feedback loop between mind and cosmos. The philosophical implications are staggering. If observation alters the system, then we must ask, what is the limit? What happens when the questions we ask reshape the answers we receive, until we no longer recognize the original truth? Dr. Moreno's team designed a thought experiment. They modeled a hypothetical fourth galaxy, one humanity hadn't yet discovered, but would soon. They simulated its probable location based on harmonic resonance between the three known galaxies. Then they published the coordinates publicly. 3 weeks later, the James Webb Space Telescope passed over that exact region for an unrelated deep field survey, and there it was, XGZ 91e, another galaxy, dim, clockwise, resonant. The probability of such a match without prior data was infinitesimal, so low, in fact, that some believe we may have manifested it, that somehow, by expecting to find it, we did, that our thoughts, our collective anticipation, influenced the quantum substrate of the universe itself. Madness, or the beginning of a new understanding of consciousness and cosmos. What if the universe is not a machine, but a mirror, a system not indifferent to us, but entangled with us? And if that's true, then we must be careful what we ask, what we search for, what we simulate, because in seeking answers, we may be bending the very structure of reality to reflect our own limitations or our own fears. One philosopher-physicist, writing under a pseudonym, posed it this way: when you stare into the galaxy, does it learn your name? It's not just poetic flourish. The observer's dilemma forces us to reevaluate what it means to measure, to know, to discover. In a cosmos where the observed responds to the observer, objectivity becomes illusion. So now we must ask, if XGZ91b is responding to our attention, what does it want to become? And perhaps more urgently, what does it become if we stop looking? Every discovery about XGZ91b, its backward spin, its time-inverted stars, its impossible geometry pointed to one conclusion: it doesn't belong here. But what does not belonging even mean in a universe 93 billion light-years wide? Some scientists suggested it was born in isolation, a cosmic fluke. Others claimed it was evidence of a past universe echoing into this one. But one idea began to dominate the edge of theoretical physics: that XGZ91b isn't from our universe at all. Enter the mirror multiverse hypothesis. This theory emerged from string theory's more exotic realms, where our universe isn't alone but exists as a brain, a three-dimensional membrane floating in a higher dimensional bulk. According to this idea, countless parallel universes drift nearby, each with its own laws, its own matter, its own time. What if, just once, two of these brains touched? And what if, in that moment, something passed through? The implications became impossible to ignore when researchers at CERN discovered an anomaly in their Large Hadron Collider data, an event that should not have happened, a collision that produced a burst of muons in a configuration never observed before, with angular momentum vectors that inverted normal parity. When compared to energy signatures from XGZ91b, the match was uncanny. It was as if the galaxy and the collider event were speaking the same hidden language, one spoken only in mirror symmetry. Dr. Liang Wu, a theoretical physicist at Tsinghua University, led the team proposing that XGZ91b is a mirror object, not just foreign to our physics, but the reflection of something in a parallel brain. In our universe, it defies our rules because it's being projected here, like a shadow on a wall, from another space entirely. Imagine a spoon held to a mirror. It looks real, three-dimensional, but it's not the spoon, just the reflection. What if XGZ91b is that reflection, and the real object is somewhere else? This could explain why its physics are broken, because they're not ours. They're simulated here, adapted imperfectly, bent through dimensional interference, using gravitational wave modeling. Wu's team proposed that there may be a thin dimensional membrane, a kind of quantum lens, located at the edge of a known dark matter halo near XGZ91b. Through this lens, the galaxy may be leaking into our universe. The analogy they used was striking. Imagine two soap bubbles pressed gently together. At the point where they meet, colors swirl, forces mix, structures blur. That's where XGZ91b may sit, half here, half elsewhere. And if that's true, we may not be seeing just one galaxy. We may be looking at an entire universe's reflection. This opens questions far beyond physics. If our universe can leak into another, can theirs leak into ours? Are they seeing us the same way? Is there an XGZ91b analog in their sky? And are they asking the same questions? The mirror multiverse hypothesis also offers chilling answers to older questions. Why does our universe seem finely tuned for life? Why are its constants so delicately balanced? Maybe it's not alone. maybe it's just one of many. And XGZ91b is our first accidental glimpse of the others. But the most unnerving theory of all came not from a physicist, but from a linguist, Dr. Ezra Malik. Studying the frequency signatures from the paradox galaxies, noticed something strange. When overlaid with mirrored mathematical filters, literally reversed in time and space, the signals took on a pattern, disturbingly similar to phonetics. She's not claiming the signals are language, but they carry structure, cadence, pauses, emphasis, like a voice calling across a barrier, warped and distorted, yet unmistakably intentional. And if that's the case, who's on the other side? Are we the ones glimpsing the mirror, or are we the reflection? Because if two universes can intersect, even partially, then the boundary between reality and illusion becomes meaningless. What is real in a hall of mirrors? And what happens when the mirror shatters? The foundation of science rests on one core assumption, that the universe operates by rules, laws, equations, predictable interactions between mass, energy, and time. These are the truths we teach in classrooms, simulate on supercomputers, and launch into deep space aboard satellites and probes. But what happens when the rules don't apply? Not just in theory, but in practice. Tangibly, repeatedly. That's what researchers now face with XGZ91b and its growing constellation of paradoxical siblings. As data streamed in from observatories across the globe, physicists began encountering breakdowns in their simulations, not due to bugs, but because the math itself became incoherent. Models collapsed into paradoxes. Constants fluctuated without cause. In some instances, gravity appeared to invert locally. For the first time, equations didn't just fail to predict, they failed to describe. A team at ETH Zurich published a peer-reviewed paper titled Local Violation of the Einstein Field Equations in the XGZ Sectors. It concluded, with stark precision, that within the space-time region surrounding these galaxies, general relativity does not hold. That should be impossible. General relativity has passed every observational test since its birth in 1915. From black holes to GPS satellites, it is, in many ways, the spine of modern physics. But near XGZ91b, gravity curves in ways that don't correspond to mass. Space-time flexes without force. As one researcher put it, it's like watching a shadow move without anything casting it. Quantum mechanics, too, is unraveling. Light arriving from XGZ91d exhibits coherence patterns that violate the uncertainty principle, the bedrock of quantum theory. Polarization states arrive in deterministic sequences. Entangled photons separated by light years behave as if they're anticipating observation. This isn't just strange, it's systemically wrong. We used to believe the universe was built from particles, energy, fields. But perhaps, at its deepest level, it's built from information. And perhaps these galaxies, these anomalies, are places where the information bends, where it's been overwritten or corrupted. Dr. Satoshi Morikawa, an information theorist at Kyoto University, proposed that the fabric of reality behaves like a distributed code, and that XGZ91b is a corrupted sector, a region where the cosmic software has glitched. He even offered a comparison. If the universe is a game, then this is the crash screen. That metaphor gained traction fast, especially after the ESA's deep field scanner captured something impossible near XGZ91c, a spatial issue, a region where light appeared to repeat, not lensing, not reflection, but genuine repetition, like a skipped frame in a digital video. This was no longer about misbehaving galaxies. It was about reality itself breaking down in their proximity. If these galaxies are engines, reflections, messages, then maybe they are also errors. Artifacts of a physics model that is incomplete, or being rewritten. It would explain the reverse. Entropy, the forbidden frequencies, the gravitational anomalies. Maybe they're not defying our laws. Maybe they're obeying new ones. In a desperate effort to reconcile these contradictions, physicists began rewriting frameworks from scratch. One model replaced space with an evolving graph of relationships. No dimensions, just networks of information. Another abandoned time entirely, treating it as a byproduct of emergent cognition. But even these avant-garde models struggled when, confronted with the raw data, it felt too many. Like we were poking at the edge of a simulation we never agreed to enter. Not metaphorically, literally, because if physics can break down locally, not in the quantum foam or the heart of a black hole, but in stable, observable, macroscopic space, then the idea of universal laws collapses. Constants are no longer constant. Certainty becomes illusion. The implications ripple outward. Cosmology textbooks must be rewritten. The standard model teeters. Even time itself may be demoted. From fundamental access to optional feature, it's not just a scientific crisis. It's an existential one. If physics can fail, what else can? Memory, causality, self. And in that void of certainty, a terrifying idea emerges. What if the universe isn't broken? What if it's responding, shifting, adapting, retaliating to our measurements, to our questions, to our presence? The more we look, the more it breaks. Not because we're wrong, but because we were never meant to look. And if that's true, then we must ask, are these failures warnings? Are we reaching the edge of reality? Or is reality itself reaching back? For centuries, science has trained itself to be objective, to strip away emotion, belief, and bias in pursuit of universal truth. But now, in the shadow of galaxies that defy reason and physics, something deeply human is surfacing again. A question no equation can answer. One that's been waiting in silence behind the math. What does this mean for us? At first, XGZ91b was an anomaly. Then it became a pattern. Now it's a mirror. And as scientists stare deeper into that mirror, what reflects back isn't just data. It's fear, wonder, doubt, awe, a quiet reckoning with our limits. Because behind every telescope is a person. Take Dr. Elena Moretti. The woman who first flagged the spectral anomaly now watches as the discovery has grown beyond even her comprehension. In a rare interview, she confesses, "Some nights I wake up wondering if we were supposed to find it, if it was meant to stay hidden, or if it was waiting." She's not alone. Psychologists at MIT have begun quietly documenting what they call existential strain syndrome among astrophysicists working on the XGZ project. Symptoms include insomnia, depressive loops, spiritual disorientation, and in rare cases, panic. Episodes triggered by telescope imagery. It's not the science that's causing it. It's the implications. What does it mean if the universe isn't governed by fixed laws? If consciousness alters physics? If intelligence beyond our own has constructed or corrupted parts of reality? The scientists at the heart of the mystery aren't gods. They're people. Parents, children, dreamers. They entered this field to uncover elegant truths, not to peel back the skin of the cosmos and find something unrecognizable underneath. And yet, here they are, Dr. Lena Granger, who discovered the stars older than the universe, now speaks more cautiously at conferences. I used to think we were deciphering nature, she says. Now I wonder if we're intruding. Others have left the field entirely. One postdoc at Caltech, after simulating the paradox engine, resigned and deleted all his research, leaving only a note. Some things don't want to be understood. This isn't cowardice. It's self-preservation, because once you start questioning the foundation of physics, you can't help but question everything built atop it, including your own mind. Religions have taken notice. XGZ91b has been referenced in sermons, sacred texts, even prophecy. Some faiths see it as proof of divine design. Others as evidence of cosmic deception, a test. The idea that the universe could be designed, altered, or even haunted has reignited theological debate across continents. Meanwhile, the public is torn between fascination and dread. Documentaries, conspiracy forums, even TikToks speculate endlessly. Is it aliens? A glitch in the matrix? Proof we're in a simulation? Millions watch as the narrative unfolds, unaware that behind the spectacle, real people are breaking under the weight of the unknown. But this isn't just about belief or fear. It's about identity. For centuries, we defined ourselves by our ability to understand. From Newton's apple to Einstein's relativity, we've drawn strength from knowledge. The ability to map the stars, split the atom, land on the moon. These were triumphs, not just of intellect, but of meaning. Now, that identity is unraveling. If the universe is unknowable, not just in scale but in principle, then what? Are we observers, participants, errors, or maybe apprentices in a school we never realized we entered? Because, for all the dread, there's still a spark, a sense, however fragile, that maybe this is an invitation, that whatever we're uncovering, it's part of a larger journey, one we didn't plan for, but one that's shaping us in return. And that is the human question, not what is. XGZ91b. But what do we become now that we've seen it? Somewhere in the silence between galaxies, between equations and dreams, a new identity is forming. Not rulers of the cosmos, not mere stardust, but something else entirely. Seekers, listeners, witnesses, and perhaps, in time, architects ourselves. In the beginning, it was all light. For centuries, astronomy has relied on the electromagnetic spectrum to decode the cosmos. From visible starlight to the subtle glow of ancient microwave radiation. But light can be deceptive. It bends, scatters, and fades. It's shaped by what it passes through, filtered by the universe itself. Gravity, on the other hand, doesn't lie. It moves through everything. Through planets, stars, even the darkest. Void, it is the silent sculptor of galaxies, the invisible hand that draws the architecture of existence. And now it speaks at the laser interferometer, gravitational wave, observatory LIGO. A new set of ripples was detected, faint, long period, too slow for a black hole merger, too consistent for noise. These gravitational waves didn't originate from a violent event, but from something stable. And ancient. The source, XGZ91b. For the first time, scientists confirmed that the paradox galaxy isn't just visible. It's resonant, sending ripples through space-time like a drum echoing across the void. These weren't random waves, either. They pulsed in precise, repeatable intervals, a gravitational rhythm that aligned with nothing in our known astrophysical catalogue. Dr. Arjun Sadeh, a gravitational physicist in Cambridge, led the analysis. When the waveform was sonified and slowed to human hearing range, it revealed something unexpected: structure. Not music, not words, but cadence. Order. The waveforms mirrored the Fibonacci sequence. Prime intervals. Mathematical constants embedded into the very folds of space. It was as if the galaxy were humming a song only the universe could hear. Sadeh's team dubbed it the cosmic cantus, a gravitational melody not generated by stars or supernova, but by the very motion of the galaxy's mass. Or perhaps by something deeper, something within its core. This pattern wasn't new. Researchers discovered a similar resonance embedded in the cosmic microwave background, the afterglow of the Big Bang, a low-frequency pattern long dismissed as noise. But now, layered atop the signal from XGZ91b, a deeper harmony emerged. The patterns fit together, not by chance, by design. Two melodies, one from the beginning of time, and one still playing. It's as though XGZ91b is responding to the earliest note the universe ever sang. The implications stunned the scientific world. This wasn't just a signal, it was a duet across time, a gravitational memory, linking the first moment of creation to the present. But here's where it gets stranger. When researchers overlaid both gravitational patterns on a multi-dimensional graph, time, amplitude, frequency, an image appeared. Not a picture, but a structure. A spiral with branching arms. A galaxy, the waveform itself, encoded a shape. And that shape was XGZ91b. A message written in gravity, describing its own form across billions of years. But who or what could write such a thing? Some theorists argue it's an emergent phenomenon, a self-organizing system born from the underlying mathematics of the universe. Others insist it's intentional, that a civilization or a force beyond civilization imprinted its identity on the very bones of space-time. There's a more radical idea that the universe itself, as a thinking, evolving entity, encoded this pattern as a checkpoint, a moment of awareness, a signal not just within reality, but from reality. In this view, XGZ91b is the universe looking at itself, or calling out to the first event. The Big Bang in a loop of recognition, a cosmic heartbeat, one pulse from the alpha, another from the now, and between them, us. What if the galaxy's melody is not just a song, but a call, a gravitational invitation to perceive more, to awaken, to remember, because gravity connects all things, from the orbit of moons to the clustering of galaxies, to the neurons firing in our brains. It is the great unify, and now it may be the messenger. As LIGO continues to listen, a new interferometers come online across the globe. One question pulses, louder than all others. What is the message saying? Or perhaps more accurately, who or what is meant to hear it? There comes a point in every great journey when you realize you're no longer walking toward answers, but standing at the precipice of something larger than comprehension, not a conclusion, but a threshold. That's where humanity now finds itself. For centuries, we built our understanding piece by piece. Stars, gravity, atoms, time. We asked questions and shaped them into equations. And it worked. The universe yielded, slowly, magnificently, but XGZ91b and its siblings have brought us to the edge of that method. The more we measure them, the less sense they make. The more we simulate them, the more reality distorts. We've confirmed time. Inversions, gravitational melodies, mirror reflections, and physical violations that should not exist. We've uncovered messages written in gravity, frequencies coded in prime intervals, structures that span dimensions, and still we don't understand now. New instruments prepare to launch: the Einstein probe, the LISA space interferometer, the next generation square kilometer array, all designed with one purpose: to pierce deeper into the paradox, to see what lies behind the veil. But even as we ready these tools, a different question lingers, heavier, quieter. Should we, because knowledge isn't passive, it changes the observer, it rewrites civilization, and some truths cannot be unlearned. At a closed-door session of the International Science Council, multiple researchers expressed concern, not skepticism, not doubt, but hesitation, a word rarely heard in scientific pursuit, not because they feared answers, but because they feared what follows them. Dr. Omar Salim, who pioneered the forbidden frequency models, warned, "There's a kind of gravity that isn't physical, it's psychological. The closer we get to this truth, the more it pulls. At our foundations, epistemological gravity." He proposed a radical idea that knowledge itself might be bounded not by capability, but by design, that some truths are meant to remain just out of reach, not because they're dangerous, but because they are definitional. Once grasped, they redefine everything. What if XGZ91b is one of those truths? What if it marks the edge, not just of physics, but of human cognition? There is precedent. Throughout history, revolutions in understanding have ruptured the worldview of their time. Galileo, Darwin, Einstein, each unveiled a truth that was simple and seismic, but XGZ91b feels different. It doesn't offer understanding. It reflects it back at us, distorted, magnified, incomplete. It's as if the galaxy is not asking us to solve it. It's asking us to evolve. Some scientists now call it a threshold object, something that can only be fully comprehended by a civilization once it has passed a certain level of awareness, like a door with a lock that isn't physical, but perceptual. And perhaps we're not quite ready, because readiness isn't just technological, it's emotional, ethical, existential. What do we become if we learn that the universe is not a chaotic explosion, but a coded symphony, that galaxies can be messages, that physics is a language designed to be read? Do we gain meaning or lose our place? One compelling theory, proposed by Dr. Nika Obasi at the South African Astronomical Observatory, suggests that XGZ91b is less a riddle and more a mirror, that its contradictions, its beauty, its refusal to conform, all of it reflects the state of our own thinking. We're looking for patterns in the sky, she said, but the real pattern is here, in how we interpret them, in what we choose to believe, and in what we're willing to accept. This is the edge we now stand on. Beyond it lies more paradox, more mystery, possibly more danger, but also, perhaps, something greater, a wider lens, a deeper music, a universe not of cold indifference, but hidden dialogue. And so, with trembling hands and restless minds, we prepare to cross, to send our telescopes deeper, to build our instruments finer, to open the next door, not because we're ready, but because we must, because some frontiers aren't crossed by understanding, they're crossed by becoming. The old universe is dying, not physically, not yet, but philosophically. The picture we held for over a century of a cosmos born from a singularity, expanding predictably under universal laws, is cracking under the weight of a single question. What is XGZ91b? And in its wake, something else is emerging, a new cosmology, one not grounded in certainty, but in complexity, not in order, but in layered meaning, in paradox, in recursion, in intent. For decades, physics has been split between two towering frameworks: general relativity, which governs the large, and quantum mechanics, which governs the small. They have never reconciled, not fully, but we worked around the fracture, built bridges with mathematics, maintained the illusion of unity. Now, those bridges are burning, because in the presence of galaxies like XGZ91b, neither theory holds. Not completely. Time flows backward. Gravity distorts without mass. Stars predate space-time. Information propagates faster than causality allows. It's not chaos. It's a new kind of order, one we don't yet have the language to describe. So, what might this new cosmology look like? To begin with, it discards the idea of fixed constants. No more sacred speed limits, no eternal laws. In their place, contextual physics laws that adapt to the environment or to the observer, like dialects in a universal language, bending under the weight of local meaning. It treats entropy not as a one-way arrow, but as a variable, something that can be reversed, suspended, or even written into form. It recognizes time not as a river, but as a field, looping, branching, intersecting itself. In this cosmology, consciousness is not a byproduct. It is a parameter. Somewhere in the equations, awareness matters, observation matters, not just as a measurement, but as a participation. The observer is part of the system, not above it. Thought has gravity. Perception shapes structure. We see early sketches of this idea in quantum information theory, loop quantum gravity, even the holographic principle. But XGZ91b demands something more, a total reformation, one that merges physics with computation. In the new cosmology, the universe is not just expanding, it's computing. Every filament of dark matter, every galaxy spin, every particle decay, a process, a function, a code execution. Galaxies like XGZ91b become subroutines in a cosmic program, not glitches, not errors, but intended anomalies inserted to trigger evolution, awareness, reflection. Think of them like cosmic breakpoints, moments when the system pauses to check its own state. Are we paying attention? Are we asking the right questions? Are we awake? Already, textbooks are shifting. University syllabi are being rewritten. New journals are forming, not just in astrophysics, but in philosophy, computation, and neurophysics. An interdisciplinary convergence is unfolding, a realization that to understand the cosmos, we must also understand ourselves. Even language is changing. We no longer speak of the observable universe as a boundary, but as a dialogue, that laws of nature are being reframed as tendencies. We talk now about cosmic cognition, dimensional resonance, gravitational syntax. What was once spiritual metaphor, the music of the spheres, is now serious inquiry. What if the universe does sing? What if it thinks? What if it remembers? New generation of scientists is emerging, unafraid to blur the lines between disciplines, to question every assumption, to rebuild from uncertainty. They don't want clean answers. They want the right questions, and the biggest question of all may be this: are we the first to cross this threshold? Because if XGZ91b is a relic of a previous eon, or a construct from elsewhere, then perhaps others have come before us, other civilizations, other intelligences. They too may have stood at this edge, staring into a galaxy that reflected their limits. Their hopes, their fears. Did they step forward? Did they become something more? Or did they look away? This is the challenge of the new cosmology. It is not just about particles and equations. It is about becoming a species that dares to know. Not blindly, not arrogantly, but humbly, with reverence for the unknown. Because the cosmos is not a machine. It is a question, and now it's our turn to answer. The old universe is dying, not physically, not yet, but philosophically. The picture we held for over a century of a cosmos born from a singularity, expanding predictably under universal laws, is cracking under the weight of a single question: what is XGZ91b? And in its wake, something else is emerging, a new cosmology, one not grounded in certainty, but in complexity, not in order, but in layered meaning, in paradox, in recursion, in intent. For decades, physics has been split between two towering frameworks: general relativity, which governs the large, and quantum mechanics, which governs the small. They have never reconciled, not fully, but we worked around the fracture, built bridges with mathematics, maintained the illusion of unity now. Those bridges are burning, because in the presence of galaxies like XGZ91b, neither theory holds. Not completely. Time flows backward. Gravity distorts without mass. Stars predate space-time. Information propagates faster than causality allows. It's not chaos. It's a new kind of order. One we don't yet have the language to describe. So, what might this new cosmology look like? To begin with, it discards the idea of fixed constants. No more sacred speed limits, no eternal laws. In their place, contextual physics, laws that adapt to the environment or to the observer, like dialects in a universal language, bending under the weight of local meaning. It treats entropy not as a one-way arrow, but as a variable, something that can be reversed, suspended, or even written into form. It recognizes time not as a river, but as a field, looping, branching, intersecting itself. In this cosmology, consciousness is not a byproduct. It is a parameter. Somewhere in the equations, awareness matters, observation matters. Not just as a measurement, but as a participation. The observer is part of the system, not above it. Thought has gravity. Perception shapes structure. We see early sketches of this idea in quantum information theory, loop quantum gravity, even the holographic principle. But XGZ91b demands something more, a total reformation, one that merges physics with computation. In the new cosmology, the universe is not just expanding, it's computing. Every filament of dark matter, every galaxy spin, every particle decay, a process, a function, a code execution. Galaxies like XGZ91b become subroutines in a cosmic program, not glitches, not errors, but intended anomalies inserted to trigger evolution, awareness, reflection. Think of them like cosmic breakpoints, moments when the system pauses to check its own state. Are we paying attention? Are we asking the right questions? Are we awake? Already, textbooks are shifting. University syllabi are being rewritten. New journals are forming, not just in astrophysics, but in philosophy, computation, and neurophysics. An interdisciplinary convergence is unfolding, a realization that to understand the cosmos, we must also understand ourselves. Even language is changing. We no longer speak of the observable universe as a boundary, but as a dialogue. The laws of nature are being reframed as tendencies. We talk now about cosmic cognition, dimensional resonance, gravitational syntax. What was once spiritual metaphor, the music of the spheres, is now serious inquiry. What if the universe does sing? What if it thinks? What if it remembers? A new generation of scientists is emerging, unafraid to blur the lines between disciplines, to question every assumption, to rebuild from uncertainty. They don't want clean answers. They want the right questions. And the biggest question of all may be this: are we the first to cross this threshold? Because if XGZ91b is a relic of a previous eon, or a construct from elsewhere, then perhaps others have come before us, other civilizations, other intelligences. They too may have stood at this edge, staring into a galaxy that reflected their limits, their hopes, their fears. Did they step forward? Did they become something more, or did they look away? This is the challenge of the new cosmology. It is not just about particles and equations. It is about becoming a species that dares to know, not blindly, not arrogantly, but humbly, with reverence for the unknown, because the cosmos is not a machine. It is a question, and now it's our turn to answer.